Hi, my name is Amirul and the cameraman is Ahmed. And today we're going to do task 2 of the measurement of the 2D smart camera test kit. So here is the 2D smart camera, as you can see, and we'll be using SSA engineering software. So when you want to configure, you double click on this application on the SSA engineering software and you will arrive at this page. So when you arrive at this page, you'll be using inspector PIM60. So with this, you will then need to double click on this thing, double click it, and this page will appear. So when this page appears, you will need to adjust the exposure here, and you will usually set around 5 ms. So with that, we will then need to use this checkerboard, which will be needed to calibrate. So you place it on the board here. Then we will press this calibrate button here. So as you can see, we need to change this to 9mm, as the board we use here is shown 9mm here. So we have to set it to 9mm to calibrate. So after that, you press calibrate. So after the calibration is done, we will then close this window. Then we will move on to Ahmed, which will show how to measure these two sensors.
Okay. Hello, this is Ahmed. So basically, I'm going to show you about this sensor 1 and sensor 2. So we're going to measure between these two sensors. As you can see, we need to use the front to front using point to point, and front to end using right angle. So this is the image of we need to do that we need to locate in this 2D smart camera. So basically we need to take out this checkerboard first, as we calibrate it. Then next we need to place these two objects to the 2D smart camera. This here. So we can display from the monitor itself. Okay. Done. So the next thing is that we need to do a teach reference object. Choose from here. Then we need to teach to the this sensor 1, and we need to object locator to the sensor 1. So basically, so this is the edge contrast and the settings. So basically, if it's green color, that means it is visible, so it's matching. Okay, so next we're going to do the point to point, front to front. So we go here, edge tool, and go to edge. And this is the front of the sensor 1, and we need to move this. Okay, as you can see, this is in red, so we need to do the edge contrast until it is shown to green color. Let me adjust it. Okay, so basically it has been changed to green, red to green, so it is the tolerance is very good. So we're going to do the next one, which is the sensor 2. Okay, so we need to change the edge contrast again, and it's green. So we need to find the distance between the sensor 1 and sensor 2 for front to front. This one. Okay, so next we're going to do the front to end right angle. But first thing first, if you want to find which type of which type you need to use for the front to front. You can see from here, point to point. But to change from triangle, you can change it. So next thing, you need to do the front to end. Change it. Okay. This is the end of sensor 2. We need to change it here. Okay. So next we do the distance. Is front to end, and we change it the type to point to right angle. And the next thing that we need to do is that we need to, for the sensor 1 is let me show you. This is the object locator for sensor 1 relative to object locator, and for X3 is relative to object locator. And as for sensor 2, we need to change it to object locator to fix in field of view. And as for the other one, this one, change it to fix in field of view. So after that, we are done and we need to run it. Pause. Okay, so next we're going to press run. And here are the results of the distance of front to front, which is distance 1, 23.82 mm. As for front to end is distance 2, 50.70 mm. So basically, if you want to move those distance, you need to move the sensor 1, which is the object locator, and the sensor 2 is fixed. So if you want to change the distance, basically from here and here, you need to move this. Okay, so there are difference from the previous one. Now it's 34 and 61, and that's how you change the distance of these two measurements, where if you want to find the distance between these two sensors. Okay, so I will pass on to Amirul, which will talk about the digital output settings.
So now I will be talking about the digital output settings. So here are the default digital output settings. As for output 1 is not located, output 2 detect failed, and output 3 all pass. So as we have found out that when output 3 will be activated when all of the edges are untouched. As you can see here, output 3 is activated when none of these edges are untouched. So when one of the edges is touched, output 2 will be activated and detect fail will be shown now. Yeah, and as for output 1, the object locator is blocked and output 1 will be activated. Yeah. So as for our assignment, we have to set the light indicator on when the result of detect failed is produced. So from here we will have to change this output from detect failed to not located and output 1 to detect failed. So from here we will see that when I block one of the edges, sorry, we have to run. We have to run and do not save. So when I block one of the edges, the light indicator will be on and the detect failed will be shown. Yeah, so that's how we set the light indicator on when the result of detect failed produced. So here you can also see the position of the edges and how the position will be calculated is from the calibration, which is 9 mm that we have calibrated from the checkerboard. So the software will calculate for us, and these positions will be calculated by the software. Yeah, that's all.